Sodium metal reacts with oxygen to produce sodium oxide. If 5 grams of sodium is reacted with 5 grams of oxygen, how many grams of the product are formed? So let's try and work underneath the equation like usual. And we're going to say I've got 5 grams of sodium, mass over molar mass will give me the number of moles. So that's mass over 23, and that's equal to 0.22 moles. If I do the same thing for oxygen, I'm going to say I've got 5 divided by 32, and that gives me 0.156. Let's do a little link. What if I said 4 is to 1 as 0.22 is to, I divided by 4, 0.54. That looks, 0.054. That looks like I would actually have enough. And we can now do a full link over here, which says that I would then produce, if it is 0.22 to 0.054, 4 is to 1 is to 2, as 0.22 is to 0.054 is to 0.11. Let's just double check the alternative. 1 is to 4 as 0.156 is to multiply by 4, 0.625. Well, 625 is quite clearly bigger than 22, so that is not possible, which means that I will run out of sodium first. I haven't got enough, so that is my limiting reagent. Then with this limiting reagent, I'm able to say I will run out of sodium first, so 0.22 of sodium will link with 0.054 of oxygen, which then is going to produce 0.11 moles of sodium oxide. So now I can actually calculate the mass of sodium oxide, because that's what they asked me, how many grams of product are formed. Mass is equal to number of moles times molar mass, 0.11. The molar mass is going to be 23 plus 23 plus 16, which is going to be 62. And I land up with 6.82 grams of sodium oxide. What have we got here in terms of what was used of the limiting, well, not of the limiting reagent, of the other substance, and then what was in excess? What was used of the limiting reagent was 0.22, which means I had nothing else left over. Here, I've only actually used 0.054 of the 0.156 that was available. So let's work out how many grams did I use. Mass is equal to number of moles times molar mass. What did I use? 0.054. That is the link. 4 is to 1 is to 2. And I land up with that being multiplied by the molar mass of oxygen, which is 32. And I get 1.73 grams of O2 used. Therefore, how much O2 is left over? Well, I was told at the beginning that I started off with 5 grams. So it's 5 minus 1.73 that I used, and that's going to leave me with 3.27 grams of oxygen that are left over. This slide asks those questions: how much oxygen was used and how much was left over, so that we've just calculated now. How many grams of solid are formed when 10 grams of lead reacts with 10 grams of phosphoric acid? So once again, let's work underneath. So I'm going to say number of moles is equal to mass over molar mass, and for lead it's 10 grams divided by 207, which is equal to 0.048 moles. Under the phosphoric acid, I can say that we have got mass over molar mass, so it's 10 the molar mass is going to be equal to 3 plus 31 plus 64, and that turns out to be 98. And so I land up with 0,102 moles of phosphoric acid. Let's try and do some links. First, let us start with the 0,48 and see what we get out of that. And we are told that it's a 3:2 ratio. So I'm going to divide this number over here by 3, multiply it by 2, and land up with 0,032. If I look, I had 0,102, so 0,032 is enough, so that is going to work out just fine. If I were to work it the other way, I would see that I have got 0,102, 2:3, divide by 2, times by 3, 0,153 moles, and you can see that this is much more than that, so it is not possible, which means my limiting reagent is going to be the lead, because I'm going to have to use 0,048 and 0,032 and see what I make. So the lead is limiting, because I'm going to run out of it first. Then I'm going to say 3:2. I'm just looking at balancing numbers. 3:2 1:3 in the same way as 0,048 0,032 is to keep going over here 0,032 and 0,048. So all I've really done is I have said, sorry, this isn't 0,032, it's 0,016. So I have said 3:2 1:3, and the 3's are the same. 2:1, chop that in half. It asks you how many grams of solid are formed, so that's the number of moles of solid formed using the limiting reagent as my mole ratio. So it was lead is to lead phosphate is the same as 3:1, and I don't have 3, I have 0,048, which means I have 0,016 moles of lead phosphate. The question wasn't the number of moles, it was what is my mass, so I can work that out, and I can say mass is equal to number of moles times molar mass. The number of moles is 0,016. I got that from the mole ratio. And now my molar mass is quite a story here. It's going to be 207 times 3 plus 2 times 31 from the phosphorus and 8 times oxygen. And altogether that comes to 811. Those leads are very heavy, and I land up with 12,98 grams of what? Solid being formed, the solid being the lead phosphate. There's a slight error over here. That must just disappear. That 9 was a number. It's not anything. 56 grams, if you look at the PDF, is of a sample of impure potassium nitrate is used in the laboratory to prepare oxygen gas. There it's given. This is how much oxygen I make. What is the percentage purity? So what I'm going to do is I'm going to see if I made 5,6 grams of oxygen, how much potassium nitrate did I need to make 5,6? And then I'll see how much of that is actually not necessary. The way I'll start is as follows. I'm going to start off at the oxygen, and I'm going to work out the number of moles. So I land up with number of moles is equal to volume over molar volume, which is going to be 5,6 given to me over 22,4, and that's 0,25 moles. My mole ratio is 1:2, so if I go KNO3 is to O2, it is a 2:1 ratio, but I don't have 1, I have 0,25, sorry, 0,25, double it, 0,5. So that's what I'm going to take up in the reaction. Then I'm going to ask, what is my mass? Mass is equal to number of moles times molar mass, 0,5 multiplied by 101, and I land up with 50,5 grams of potassium nitrate. But I don't have that. I've got 56 grams. This is the total for the test, 56. This is what I got for the test. So how do I calculate the percentage purity? I'm going to try and make it. I'm going to say percent pure. What was the total for the test? It was 56 grams. And what did we actually get for the test? We actually got 50,5 grams. And therefore, if I times that by 100, I will get the percentage purity, and it turns out to be 90%.